Okay, if you want to put your computers down, we won't be needing it for the first half. Okay, we'll do that after we go through the lesson. So we're going to do section 1.3, which will complete chapter 1. Couple issues. Don't worry about the due dates. I'm still updating them, but all so far, if you've gotten 1.1 and 1.2 at least started and hopefully finished, that would be great. We'll do 1.3, and I'll work through the tests, due dates, and everything. Also, 10 of you are signed up for 2 of the Pearson classes. And that's my fault for, I tried to get one to link to Canvas, and it's the one that has 4th at the end. So 10 of you have registered there, but you're also registered in the main course. What I believe will happen is you only signed up for one with your authorization code, right? That pays for the class. The other one is on a 2-week, they give you 14 days free, and then they cut you off because that's how they get you started. So I believe that second course that you somehow registered for, maybe through Canvas, will cut off. But I will transfer over any work. A few of you have some work in the other course. I'll deal with all of that, and eventually we'll all be in one course. But otherwise, since I created the problem, I'll fix the problem. Okay, so just keep on going into Pearson as we go and doing the work. So we're going to do 1.3. I believe it will take most of the time period to discuss it. You can you have the note sheet to kind of follow along, and then that way tomorrow when I'm not here, you can be working on 1.3, and we'll make sure everyone's signed into one of the courses. Any questions before we start in? Okay. Okay, we'll get you set up. With that, yes. We will have time. What we'll do is we'll do Thursday. We'll tie everything back together. Yeah, because nominal, ordinal, those are basically our 2 types of qualitative data. The other 2 are a little tricky, but let's go ahead and get through it. There's also, in Canvas now, the second link is the recording. So if you missed class, we recorded it. And what I'm doing right now is also, this is being recorded. So the screen and my voice, and anyone who speaks loud enough to this microphone to pick it up, will be recorded, and then we'll post it at the end. Okay, so we can always go back and pick things up. This is what's new, section 1.3. I added a new slide deck. I'll keep updating as we go. This will get you into the homework. But what we're going to do is start off right here. So we've done 1.1 and 1.2. We did that in one section, one day, really. And then 1.3 we're going to do today. So 1.1, 1.2 is checked off. That's all in that recorded section. And again, even if you were here, it's a good review. You've got the notes, ties in with the PowerPoints. And hopefully that repetition of looking over the material will make it come alive. We'll work on the homework, and we'll have some time for review and quizzes as we go. The other thing is, I'm still planning out, but typically what we do at the universities I've taught at is we don't test you on each chapter. So we're going to use, there's some chapter tests in here. We'll use those as sort of practice for the test. We'll test you on, we'll do one test over about 3 sections. So we'll have about 3 tests throughout the semesters that will count. The other ones will be practice and get you ready for it. If you do well on them, that means you'll also do well on the actual ones we take. Okay, but by the end of the week, I'll have a whole schedule set up for you once I get into this curriculum, see how it works. Okay, so what we're going to, by the end of the day, what we will know how to do. We'll know how to design a study. And notice there's 2 different types. There's an observational and an experiment. Does anyone have an idea from those words? What's the difference between observational study and an experiment? What do you do? Yes. So an experiment, you're doing something to them, maybe like a surgery or there's a treatment. That's an experiment. Observational is just what's happening, right? You're not trying to influence this. You're just trying to say, what's your opinion? So observational is just to see what's going on. Experiments actually try to change what's going on with a treatment. Good. Uh, we collect data sometimes with either a survey or a simulation, like with a computer. We'll talk about that. And you'll know how to make a representative sample. We talked a little bit about sampling methods, right? Or did we? Or is that, we're going to do that today. But we've talked about the difference between a sample and a population, right? And the sample is helpful as long as it looks a lot like that population. If it's very different from the population, maybe a segment, it's not going to be represented. Then our study doesn't really have much value. So that's the importance. So what we're learning today is how to make a study that will have value. Maybe not how to make one, but how when we see a study to see, is this stuff really, is it really worth even looking at? They got this results, but does that mean that that's really what's happening? Okay. So steps for designing a study. There's kind of going to be two sides to this. One side is we have to identify the variables and the population. Now we've talked about a population, right? It's the group we're interested in. What's a variable? Yes. Variable means it can change, and it's what we're interested in, right? What's your opinion about the weather, right? And everyone would have that. The variable would be how everyone felt about the weather today. Some might love it, some might hate it. I don't, whatever. So, but that's a variable. So we have, when we do a study, what do we want to know? What are the variables we want? And there might be more than one. Okay. Secondly, then that's when we develop our plan. How are we going to collect the data that gets our variables, right? How are we going to, knowing our population, how do we get that sample from that population so that it's representative? There's this many women and this many men, so we have kind of that same sort of mix in it. Okay, then what do you think we're going to do? What are we ready for once we've done all this planning? Collect the data. Good. And then that's that step. And that's basically the experimental part, right? We've done everything, or the observational part. This applies to both experiments and observational studies. We've got our data. Now what do? This is a part where we might think mostly of statistics, right? We're going to take that data and work with it. So I've restarted the numbering. The first step after we've got basically the study complete, we then go into the analysis. We're going to use descriptive statistics to try to understand what's going on. What is this data saying, right? Just what do we know about this sample? And what are some descriptive type of statistics? I know you know some of it. What is the number if like that's in the middle? What would you call that? A median, a mean, both of those words apply, an average. So that's a kind of descriptive statistics that we will calculate. Those kind of things, along with some other things. We're also going to use inferential statistics to connect that sample to that population. Okay, so this is the time we'll do that. And then this course we will learn how to do both. So I think there's a whole chapter on each of those. So we'll get pretty much details on how to do the descriptive statistics. We'll spend a whole chapter doing that, and then we'll also spend a whole chapter doing the inferential statistics. How do we tie that sample to that population so we have something of value? Now, there's one more thing left to do. What do you think that is? Yeah, you got the notes there. Exactly. See if we made any mistakes. Is a study valid, all this kind of stuff. Maybe we have to repeat the study for something else, but yes, see if there's any errors. Good. Okay, so that's how the sort of the life cycle of a study. Now, some people do all 6 of these steps, right? You're doing your own study. You have to do your own analysis. Other things, you'll have a group that is involved in the data collection, and then you'll have another group that is involved just in the statistical analysis part. So, just depends on how big your grant is, right? If you got a whole team, or if you are the team. Okay, so data collection. For an observational study, how are we going to collect data? Well, you sit and you watch. Maybe you sit in the back of a classroom and you take notes. That's an observational study. You could also measure things. Again, you're not trying to influence things, but it might involve measuring, the size of someone's pinky in relation to the size of their arm. Something like that's an observational study. You're not trying to influence anything. You're just trying to see, is there a relationship between the size of someone's pinky and their size of their forearm or something. Okay. So here's an example. Researchers measured the amount of time people spent doing things like paid work, childcare, socializing, watching TV. And again, a lot of observational studies, what they ask you is, you tell us. We're not going to sit and watch what you did all day long. You're going to tell us, oh, I watched TV for 2 hours. I worked for 5 hours. I took care of the kids for this long. So that's a way of doing an observational. Again, no attempt to influence, just to, hey, what's going on? When we have an experiment, typically, not always, but most of the time, we're going to have 2 what we call experimental units. These are groups. Okay. And in an experiment, how is an experiment different from an observational study again? Yeah, we're trying to make some changes. We're doing something. There is a treatment of some sort. Maybe a class you take, maybe a shot in the arm, maybe a pill you take, something, right? So there is a treatment that is going to be applied to one of the groups. And what do we call this group? Well, the treatment group. Makes sense. So sometimes we got it right on the naming, right? Treatment group is the one that gets the treatment. And we watch how they respond to that treatment, whatever that treatment is. Okay. Second group, we basically want a group that we didn't do anything to, so we could kind of get a baseline and see if we improved over doing nothing. Okay. And we call that a control group. We just want them to go about their regular lives doing what they do and be able to measure that. Now, one of the things is, though, when people know they're part of a study, if they know that they're getting the treatment or they know they're not getting the treatment, sometimes that causes psychological bias, because, oh, I'm getting something, I should get better, so you get better. Oh, I'm not getting anything, I shouldn't get better, so that you don't. So they call that a placebo. If they're going to give a pill to one group, they'll give a fake pill to the other group so that they don't know that. Okay, so the word placebo is just a fake treatment. Oftentimes in education, like we would teach a class and we want to teach it in a new way to make a difference. What we do is we take the control group, we teach them something that doesn't even relate, and just see if it makes a difference. Okay, but they thought they were getting something. So that's that placebo. So here's our first little thing. We want you to decide, and just give it a minute, but decide whether this is an experiment or observational. So researchers study the effect of vitamin B supplementation among patients with antibody deficiency and frequent respiratory tract infections. 70 patients received 4,000 international units of D3, vitamin D3, daily for a year. Another group of 70 patients receive a placebo daily for 1 year. Is this a study or an experiment? Well, it's observational study or experiment, and why? Okay, if you can put the computers down, put the lids down, because we don't need those right yet. Just all the way, all the way. There we go. Experiment or observation? Experiment, why? How can you tell? Two groups, one getting it, one getting a placebo. Good, very much. Same thing, yeah. So we're looking for, is there a treatment? And then also a giveaway is if there's two groups, one that gets it, one that doesn't. That's always going to be there. Well, occasionally they don't have a control group, but um, most of the time they will. How about, so there it is. It's a treatment, right? How about this one? Researchers conduct a study to determine how confident Americans are in the economy. Researchers call 3,040 people, U.S. adults, and ask them to the current U.S. economic conditions and whether the economy is getting better or worse. Observational study, experiment. Observational study, why? Okay, so they just asked them. They didn't try to influence them, did they? They didn't give them a spiel of why the economy's so good. Now, what do you think? No, that's so no treatment. There it is. We could change this into a study by maybe having them look at something, but there was no treatment. So that's the key part. That vitamin D, that could have been an observational study if we just, let's see how many people are taking it and if they're better or not, you know. But when you do the treatment, when you say, okay, you're going to take this much, then it's an experiment. Okay. When we collect data, one way of doing it is with a simulation. This will work for various regions. And what we do is we do a mathematical model. So maybe like we want to study hurricanes and how to maybe survive them better or something. But we don't want to bring a hurricane really bad, you know, to our neighborhood, mess up all the houses. So we do a mathematical model. We have a computer run it, and we can maybe figure out ways to build better, stronger houses that could, sustain the wind. Computers are often used in this. It allows us to look at dangerous situations, like the middle of a hurricane, without actually putting anyone at risk. The other thing, car manufacturers, they use this all the time. They have those crash tests. They don't put people in and let's see how badly they got banged up. No, they put test dummies that have sensors, and then they can tell. They simulate what's going to happen, okay, without putting anyone at risk. Making sense so far? So multiple ways to get data. And again, what we're getting you is you're getting this foundation as we go into this is we're going to look at a lot of different types of studies, both observational and experiments. We got to be able to identify these things. And then we're going to analyze the data, because how the data was collected also determines how we can analyze it. Good. Another thing we can do with, and this specifically with observational studies, is we can have a survey. Now, survey sounds like an easy thing to do, doesn't it? You just ask people their opinions, right? But it's not so easy. There's actually a whole college class. I took one, a whole another 3-credit class, just how to make a survey, because you got to do all this thing. It's we're looking for what characteristics. So in the survey, you've got to say, what are we trying to find out? We got to make sure we ask questions about all of those. You make a survey and you forget to ask about one of those things. Oh, let's go back to these 500 people and ask them again. It's not going to work. You got to get it right the first time. And that, as you saw that one, they ask people questions. They can be done through an interview, orally, through the internet, through the phone or mail, through forms that you fill out, right? And when you design a survey, it's very important the way that you word the questions. You don't, and we'll talk about this in a little bit more detail about bias. Sometimes if you ask a question one way, oh no, I would never do that. If you ask it basically the same question in a different way, you might get a different answer. Those are the details of a survey. So how you ask the questions, the order you ask the questions, and all those are important. Okay, so surveys, and also we're going to see whenever we're doing an experiment, what's the number one rule of experiments? You're trying to find out information, but do you want to hurt anybody? Safety and not hurting people. Surveys, you could, if you ask it in a way, you could hurt somebody's feelings, and maybe even more. I mean, so that's, I mean, there's something called an IRB, an institutional review board. Whenever you're doing research, they'll go through and they'll say, nope, that question's too pointed. You're going to hurt somebody's feelings. So safety all the way around, not even hurting people's feelings. So they watch out for that. Again, we're not going to get to that depth of it, but just to let you know, if you do get into something that's going to do research, you'll take a whole class just on how to make a survey. And there's a lot of details in there. So here's just an example. They did a survey on physicians to determine their primary reason. Why did you become a doctor? Is it financial stability? Because you think doctors make a lot of money. And one survey, you could just leave it open-ended, or you could ask, you could give several examples. You could say, A, you want to make a lot of money. B, you want to help people. C, you think it's cool. So you could give them some reasons and they could choose. So that would be a survey method. And you've probably seen these where you take a survey and you choose. Sometimes you fill in a blank, but survey data. Okay. What might be the advantage of giving a list to choose from versus just leaving it open-ended? Just a blank to fill in. Right, they did 1 of 4. You can graph those, or just 1 of 4. If you got this, there might be 20 different answers, and they don't go. So yes, you don't. So that's again the design. Do you want to limit them to a few choices for analyzing your results? And a lot of times, I remember, and I took the survey class. They had you do one, and I missed a lot of stuff at the first because you don't think about everything at the beginning like you're supposed to. At least when you're new to it. But anyway, it'll get you there. When we're doing an experiment, now remember this involves a treatment, so there are 3 very important things. We've got to have control, usually a control group, but also control over what's going on in our environment. We want, again, if we're testing out a new cold remedy, does it help them get over the cold faster? We've got to have some kind of control that there's something else happening, getting reinfected or something. Randomization is important in an experiment so that our subjects are chosen randomly. Again, that helps with getting a representative sample, but it also helps us to not just, all the sick people over here, all the healthy people over here, so we're seeing if our treatment really works. And the last one is replication. We could do it again and get similar results. That's how they do it. So especially for medicines, they have to do several trials. They have to replicate it. And then it's, okay, your medicine works. And I don't know if there's this decongestant, an ingredient that had been used in medicines for over 30 years. And they finally decided they don't really work. This doesn't work better than placebo. And you're saying, why? I've been taking this medicine for all 30 years and it never got me cleared up. Now I know why, because they must not have done the work the first time right. So importance, okay? The other thing that can happen is something called a confounding variable. Now, here's an example. You got a coffee shop, you remodel it, and your business picks up. Wow, it must have been the remodel, right? Well, what if at the same time up the street they built a new mall, so maybe that's bringing more people to your area. Maybe you're getting more business because of the mall, not because of your remodel. So that's the confounding variable type thing. So looking for everything that's going on. You're growing plants and you're testing out a new fertilizer, but you put some plants closer to the window and others not. Maybe it's actually the sunlight from the light, So you got to watch out how you set everything up. There can be these what's called confounding or confusing variables that you hadn't planned for, and they're actually messing with your results. Okay, so those have to be planned for. The placebo is oftentimes a helpful way to deal with that, but there's also this placebo effect where just because people are getting a medicine, they start to feel better. And so that's why we use it to see, hey, is it the effect of just taking something that makes the people healthier, or is it the actual ingredients in the treatment that we're giving them. And then this is how we can address it. And there's two types of this. It's called blinding, like putting a blinders on, is we don't let the people, well, let me go to the next slide. Two types of blinding. There's single blinding where the participants in the study don't know whether they're in the control or the treatment. Okay, everybody gets, testing a vaccine, everybody gets a shot in the arm. Some have the vaccine, some have just a saline solution. Okay, so that's one way of blinding. The second way of blinding, though, that is also important, is the experimenters who are working with the people, they also don't know, because that could also influence it in some cases, especially like anger management workshop. You know, if you know that this one's getting the treatment, maybe you judge them to be less angry than the other or something. So the people who are collecting the data don't know. That's a double blind. Somebody in the background knows, they've been assigned numbers and they know who's getting the treatment, who's not. But that doesn't come out until they start to analyze that second part, those second three steps. Okay, the data collection is all done with people not knowing. We go till, okay. Three other important things: random, random, random. So different types of randomization. It's a process of randomly assigning subjects to the different treatment groups. And we're going to look at a couple different ways this can be done. But again, you could take a whole class just on random assignment if you're getting into experimental design. You can completely randomize, which means at the very beginning, even the people who are the sample is was randomly chosen. Okay, so, and we'll talk about that. There's also a randomized block design where you divide subjects into groups by a characteristic, maybe male and female, maybe by age, and then from those blocks you randomize. We'll take a look at a couple of those. So here's a randomized block design. You can kind of read over that, or you could just look at the picture. You take everybody, all the subjects that come in, you break them, you first assign them to the age group they're in. Again, there's no randomization. If you're 35 years old, you go in the 30 to 39 group. So it's not random, it's by how old you are, right? So you break them, but then within each age group, you randomly assign them either to the treatment or to the control. Okay, and we'll look at how random assignment can work. Make sense? Okay, so no randomness at first, but get them into the categories we want, because we want to see if there's an age effect on the treatment we're doing. So get them in our age group, and then we treat and don't treat. Maybe we divide them into male and female. Maybe we divide them by some other method. Okay. There's also a matched pairs design. Again, this is just kind of giving you a lot of things out there. And what you do is you find two people who are very similar, you match them, and then you randomly flip a coin, I guess. You know, one goes to the treatment, one goes to the control. So it's kind of by person saying, okay, if this person finds someone that's close as we can to this, and then we'll make one a treatment, one a control. Matched pairs design. Sample size is important. Okay, how big of a sample we get, generally the more you have, the better. Although there are some things that some research like that Facebook did, they had too much data. Sometimes you have too much data, you can almost say anything about anything, the way you analyze it. So you don't want to have too much, but you also don't want to have not enough. So if I want to study the effect of a vaccine, would it be enough to get just two people, give one the vaccine and one not the vaccine? No, because there might be something about this person or that, so we want to have enough of a study where we can see the average effect. Okay. What you'll find is, like, especially for class type research, there's the magic number is about 30, and we'll see why that is when we get into analyzing the data. If you're 30 or above, the statistics work better for a lot of this stuff. If you're below 30, oftentimes there's the error within that research is higher. Okay. However, just again, there's no magic number. I can't say if you have 30, you're going to be fine. A lot of times, though, depending upon what you're doing, statistically, the tests, 30 or more gives you what you need. Replication. Does it make sense? If it worked once, it should work again. If it's really that, if it was just that it was a full moon that week and that's why they got results, when you redo it with a not full moon, oh, it's all different. So what is the effect? Yeah. So test a vaccine. Yeah, maybe 10,000 people are needed. That would help. And then if you did it again and got similar results, you could say, hey, our vaccine is working. Now we'll get into the sampling techniques. First, when I asked you all about what type of interest you had, that was really a survey, wasn't it? That's just a very open-ended survey. What are you interested in? Maybe I could fix it. How many of you did I ask to do that? All of you. So that was a census. I was taking a census of the class. Okay. I didn't sample you. I didn't ask one from each table. No, I asked all of you. So that's a census. That can be done in smaller groups, and some of the homework assignments we talked about, like the Congress, House of Representatives had this many people. We could do a census for that. But typically, census is too much. You can't find all the people in the U.S. So we do sampling, and again, we've talked a little bit about this. Sampling is taking part of the group. The key thing we're looking for with sampling is what? We want that sample to be starts with an R. It's not on the board, but representative, right? We want it to be representative of the population. So basically, it's like we could get in here, and the results we get, we can apply to that population. And that's what we'll talk about, is how to get that. The bottom line to remember, though, is even if you do everything right, you follow all the rules that we're going to talk about, you get your good sample, you do all these things, we can still have error. And you'll even see it in the news, right? They report a sampling that, like with elections, this is what, so-and-so is leading by 65%, plus or minus. There always is error in their reporting. So it's not that we can eliminate error, but we should at least be able to calculate it and know how much error is involved in what we're doing. And we could do that with our techniques we're going to learn. Random sample, what it means to be random is not just to pick, roll a dice and pick somebody, but the fact that everybody in the population has a potential to be part of the sample. You have to have that happening. And then randomly, you choose from everybody. Now, if I were to do it off of people's driver's license, I want the whole population of the US, and I go into the database to find driver's license, would that be a true random sample? Why not? Not everybody has a driver's license, so not everyone could be chosen for my study. I want everybody. So I have to make sure that wherever I'm getting my data source, that everyone in my population could be. Now, if I want to know about this high school and I went into maybe student ID numbers, would that be a valid way? Yes, because it does include everybody in the school has to have an ID number. Otherwise, you're not in the class, you're not in the school, right? So there's ways that will work in one situation, but maybe not in another. Now, if I wanted all drivers, then yes, go to the drivers, pull from there. Because if they don't have a license, they shouldn't be driving, right? A simple random sample. So there's a random sample, but a simple random sample is a little bit more strict. It says every possible sample of the same size has the same chance of being selected. So again, a very detailed, but the thing you want to remember about randomization, everyone potentially has the same ability to be chosen. We're going to walk through one method of doing this. And so one way is you could use a table of randomly generated numbers. Those exist. I guess once they're on there, they're no longer really random, but we'll talk about that. You would assign a number to each person in the group that you're trying to choose, and then members of the population that correspond to those numbers become a member. So here's an example. We had 731 students enrolled in the statistics course at school. We want to form a sample of 8 students to answer some survey questions. Select the students who will belong to the simple random sample. So first, each student gets a number 1 through 731, because that's all, everyone will get a number. Then we go to a table and we start randomly, well, we take the numbers that have randomly been generated. So let's take a look. Here's a table of randomly generated numbers. So the computer randomly just generates these numbers. The thing is that since it's printed now, it's sort of not random anymore. So if we always started with the first number, we'd always get the same results, wouldn't we? So when you use a random table, the first random part of it is you have to go somewhere in the table. So they randomly pick a number, which they've got highlighted there. And then what they're going to do is they're going to break it into 3-digit numbers. So there's 719. You can see this next number is 662. So even that space there will make that number 662. And then 738. Okay, so kind of highlight, read the digits in groups of 3, because 731 people is what we have. So we need up to 3 digits. What do we do with anyone? If we, so there was one I got 738, right? We have to ignore that one because there's only, our biggest number is 731. So what we end up doing is, you can kind of see, starting with, they've got the 719, so that student's going to be in the group. 662, that student's going to be in the group. 738, that's too big. There's nobody who has that number, so we just ignore it. And we go to the next one, 650, 004. You can see on the table up there, by blocking it and taking every third sets of 3 digits, you could do that. And in that way, they pick the 8 students. Okay, so that's random assignment. All of the 731 students had the ability to be in this sample. Now they are. Does that mean all 8 of these are going to go take the survey? Not always. So sometimes you need a backup. Maybe you have to choose 10 or 11. And if someone doesn't want to do it, you can't make them do it. So then you choose the next one. Okay, make sense? But I just wanted you to see at least one way, just so it's not some like magic thing we put in the computer, and the computer could do it, but here's another way. And oftentimes when you're doing research, they want you to have some way of backing up what you've done. So this can do it. We go till, oh, we go to all the way till 10. Okay. 10 minutes, okay. Stratified sample. So here's another way to do it, is sometimes we want to break them into groups. And in this case, they wanted to get some information about households, but they wanted them by their income group to see if there's a different response by income. So low, medium, high income, and then randomly select from within those groupings. So you first find out what their income is, put them in their group, and then you randomize from each of the groups. Maybe you get 10 from each group, something like that. Does that make sense? So that's a stratified sample. Cluster sample, kind of similar. You divide the population into groups, clusters, and select all the members in one or more, but not all of the clusters. Okay, so this comes in a lot of times with areas of where people live. So you could do it by zip code. So you choose a zip code and maybe a couple different zip codes, and then you randomly select from within those. Could there be some problems with that? Yeah, maybe this zip code has a certain type of person and this zip code has another kind of person. So, you know, there's things that can happen with this. But it's been done where, yeah, you just, if you live within the zip code, then we will randomly choose between that zip code. Systematic. This is often done in manufacturing. Anyone going into engineering? Okay, design, yeah. So you want to get quality control. So systematically, you're going to check every 100th or every 50th or every 10th. You're not going to check them all because you just can't do it. So you sample, taking every so often. When I was a kid, I'd go to up to the mall. I was in Oregon. We didn't have air conditioning, so summers I would go to the mall to get air conditioning. We'd hang out, and there was this research firm there, And sometimes we had nothing to do, so I'd go up and say, hey, I'll ask your survey. They wouldn't take me because I was, first of all, we'll see that's a problem when you volunteer. But secondly, I started watching what they did is they count how many people walk by and then they'd go to it. They were doing systematic sampling in the mall. And I wasn't the fifth one, so that's why I couldn't do it. So, and then plus I was a volunteer, and I was a kid. I don't know. I was 12, 13 years old. So all those things. Convenience sample. This is an easy way to do it, right? Convenience is easy, but it's not always the best. Rarely is it the best, but it's something, oftentimes you can start a study. Let's see what people's opinion are. Well, let's go to the lunchroom and just ask some people at the lunchroom. Well, if people aren't eating lunch, you don't have them. So here's a few for you to decide. What type of sampling is this? You divide the student population with respect to majors and randomly select and question some students in each major. Which kind of a sampling is that? There is a random part to it, but it's also a specific name. Was the randomness done at the beginning? Stratified, right, because we're stratifying them into their majors, and then we're randomly selecting. Okay? Questions? Any questions back there? No. Okay. So stratified. Good. Next one. You assign each student a number and generate random numbers. Then you question each student whose number is randomly selected. What is that method called? Systematic means you only choose every so many number. So this one is random from the beginning. Simple random would be, because everyone in the group gets a number, so it would also be a simple random sample. So sometimes it's just, that was obvious, that the consistent use of random. Okay. You select students who are in your biology class. Convenient, very convenient. I got to do a survey. I'm in biology class. Let me ask these guys, right? That is a convenient sample. Question? Still? Okay. So convenient sampling is it's just very easy to do, but there's really no randomness to it. There is no, you're just taking students who are readily available. Now, if I went and asked every fifth person in my biology class, then I could make it a systematic, right? That would be systematic. At least do something with it. Okay, we're almost here. Almost done. These are the things we need to avoid. Bias, the things that bring in bias. What is bias? But it's in statistics, it's not just a favoring once or twice, but a systematic favoring in the data collection process. So something in our design is causing this bias. We don't intend, it's not saying we're intending to get this bias, although sometimes that is the case, right? And we'll talk about that. But we get inaccurate results because of this. So systematic error. And so we got to watch out for it, because we may think, oh, I'm good. I'm not going to try to do this. No, it can still happen anyway. What causes bias? There's some design issues where bias can streak right in. We talked about this, lurking or confounding, maybe call them confusing variables. We didn't consider everything. There was something hidden going on. There was a leak in the water tank or something, but it's messing with our data. because we didn't consider something, and that's a lurking variable. Confounding means, yeah, I get more, I put these plants by the window, so they're getting more sunlight than these plants. I didn't intend that to happen, but that's what happens. Okay, lurking or confounding variables. Overgeneralization. Now, this is sort of after I've done things, if I've done my research, and then I apply it to everybody. I had one sample, maybe one classroom. Hey, I taught them and they did great. So it's going to work for everybody. That's overgeneralization. Maybe it worked for other reasons. Okay, so that can create bias. Other sources, sampling bias. So if we get a sample that is not representative, there's bias in it. Maybe we picked more women than men, or something, or more 40-year-olds got into the sample than the other. So it's not going to be representative of the population. Okay, and again, sometimes this just happens even with doing the best we can. So we go back and review. This is like the last step. We check for errors. This is something we want to check for. Is our sample really representative? Self-interest study. This, believe it or not, happens a lot at universities, or it can, because a lot of professors, they get a grant to do study, and that grant is continued upon making progress on their idea, right? So you want your data to look good, maybe you're going to fudge it a little bit. It's happened. So we want to look at that when a study's been performed by the restaurant that says they have the best food in the world. Are you really going to believe it? Because it's now, if a third party comes in and they got something to back it up, that's better. But when someone's doing their own study and they have a benefit from how that study comes out, that's something to be worried about. The other ones has to do with the types of responses. So this is like when I was a kid, they wouldn't take me because I volunteered myself. Volunteers oftentimes don't give good results. So there's voluntary response bias. There's also the non-response bias. Those people we randomly selected, those 8, if they don't come and tell us, and there might be a group that just, hey, I'm not going to talk to those people. We miss a whole particular opinion. Non-response bias. There's also response bias. People don't always tell the truth. And maybe not on purpose, but they hide things. Perceived lack of a privacy. I'll say that. It's easier for me to say privacy than that other word. But they don't, like when your employer, they ask you, how do you like work? Oh yeah, I love it. Because if I say I hate it, if I tell them the truth, they're going to fire me, right? So you're afraid that your responses will result in a bad treatment of you. So you're not going to tell the truth. So that's a problem. Loaded questions, so the way we ask a question may make it hard for someone to either say yes or no, because again, the way it's asked. There's a whole class you'll take on how to word questions correctly. And finally, the order of the questions on a survey can make a difference. If you ask them this way, people will respond that way. If you ask them in a different order, they might, So oftentimes leading people to the response you want them, you can do that. And it's not going anywhere. What does that mean? It means we're done for the day. So the next step is go back through your notes, and we're just right on time here. And then I won't be here tomorrow, but we want you to get into 1.3. And when I come back on Thursday, I'll get you a map out of where everything's going. We'll get any issues. Someone emailed me about a due date, which I was able to fix. So if you have any problems, send me an email, okay?